I started to talk about the correlation, and mainly I talked about R square, which is ESS by TSS, which measures the goodness of fit, Okay, and from the very definition of R square, we found that as number of explanatory variables in a model increases, ESS increases, TSS remaining constant. If ESS increases, that will improve the goodness of fit of the model. Okay, so I stopped there. Today, I'll add some notes on this R square. Okay, so I'll start with some notes on different types of R square, which may appear in context of regression analysis. Okay, so in context of regression analysis, you will find that three types of correlations are very, very important. Three types of correlation. Three types of correlation will basically emerge in different contexts of our regression analysis. The first type of correlation is the simple correlation, which is Pearson's product moment correlation coefficient. And as you know, it is covariance xy divided by variance of x into variance of y. It measures the linear relationship among the variables. Okay. Now, while I defined R square yx, I am considering it is a two-variable model. So I have y as the explained variable or the study variable and x as the explanatory variable. So I am considering R square yx, which is covariance xy divided by variance of x into variance of y. Now, it is not necessary that we can estimate simple correlation only between two variables. If I have a number of explanatory variables in the model, that is x1, x2, x3, x4, say, 4 explanatory variables in the model, that is, demand is not only the function of price, rather we have observations on price of substitutes, we have observations on income, we have observations on education of the demander or the consumer. Suppose we have several other variables too. So in that case, that I can measure the correlation, simple correlation between R square, x1, x2, x3, x4, etc. Okay. So I can consider the correlation between quite a number of variables. It can be considered among explanatory variables. It can be considered between y and several x. It can be considered between y and a single x. You can consider x2 and x3 and you can calculate simple correlation between them. So simple correlation or the Pearson's product moment correlation can be considered between y and some of the explanatory variables, y and one of the explanatory variables, several explanatory variables, etc. Please take note of the fact that, however, in regression analysis, when we will have more than one explanatory variables, however, in the regression analysis, when we will have more than one explanatory variable, more than one explanatory variables, we consider the simple correlation among all explanatory variables. We consider the simple correlation among all explanatory variables. Thus, if we have k number of explanatory variables in our model, k number of explanatory variables in our model, we consider R square among x1, x2 up to xk. We consider R square among x1, x2 up to xk. If the correlation is high, if this correlation is high, that indicates, if this correlation is high, that indicates observations of different variables, observations of different variables are related to each other, are related to each other. So what I'm trying to tell you, if I have k number of explanatory variables, actually I have a matrix we have this kind of matrix of explanatory variables, where first subscript indicates the name of the variable, say price of the commodity, and the second subscript indicates n number of observations on price of the commodity. Similarly, say x2 indicates price of other commodity, and 1 to n, that is second subscript, indicates observations on that x2. In the similar fashion, we will move up to xk. K is, say, income. So I have n number of observations on income. So first subscript indicates the name of the variable, we are considering, whereas the second subscript indicates the number of observations we have. Now, if I consider the correlation among the explanatory variables, and if we find this correlation is high, that indicates this column is interrelated to, say, rest of the columns, or there may be interrelation between this column and, say, several other columns. Not all. So all these things, all possibilities are there. If R square is high, there is a possibility that, there is some relation between price of the commodity, price of the other goods. There is a functional relationship between income, education, income, and price. So all these possibilities are emerging. This problem, if please add, if the columns of X matrix, if the columns of X matrix are interrelated to each other, if the columns of each matrix are interrelated to each other, this is known as multicollinearity problem in the literature of econometrics. This is called the multicollinearity problem. Multicollinearity problem. And in presence of multicollinearity, we do not get efficient estimators of regression coefficients. We do not get efficient coefficients of regression coefficients, and hence we need to remove this problem. Hence, we need to remove this problem before starting the estimation process. Before starting the estimation process.
ম্যাম
Yes.
ম্যাম বলছি ওই ডিফারেন্ট ভেরিয়েবলস আর রিলেটেড টু ইচ আদার এর পর থেকে একবার বলবেন পুরোটা।
If the variables are related to each other or the columns are related to each other, this is known as multicollinearity problem. Okay, columns are linearly related to each other. This is known as multicollinearity problem.
ওকে ম্যাম।
Okay, and in presence of multicollinearity, we cannot derive is efficient estimators of the regression coefficients. We cannot derive efficient estimators of the regression coefficients. And hence, we need to remove this problem before starting the estimation process. And hence, we need to remove this problem before starting the estimation process. Okay, so I hope you are understanding this concept of R square. Simple R square is very, very important in case of regression analysis. Okay, mainly when we will extend this model for a number of explanatory variables, we use the concept of simple correlation to check whether there is multicollinearity in context of a regression analysis. If there is multicollinearity, we have to remove that problem and we will derive the estimated values of the parameters. Okay, so simple correlation is very helpful in understanding whether there is multicollinearity in the regression framework or not. This is all about the simple correlation. The second type of correlation, which is also very important, that is the notion of partial correlation. Partial correlation. Now, what is partial correlation? Look at the definition of the partial correlation. Partial correlation is correlation between y and one of the explanatory variable given the rest. Partial correlation, please add. Partial correlation measures the correlation between y, that is the study variable, and one of the explanatory variables, given the rest. So if there are 4 explanatory variables in the model, it can be y, x1, dot means given, x2, x3, x4, or it can be y, x2, dot, x1, x3, x4, etc. So the correlation between the study variable and one of the explanatory variables conditioned on the fact that rest of the explanatory variables are there. That is how price of the commodity can explain the variation in demand given price of the other commodities, income of the consumer, and education of the consumer. Say, if I have these variables in our analysis, okay? Or it measures the correlation between demand and education given the rest, this kind of idea. Okay, so partial correlation, if I consider again a k number of explanatory variables in the model, so partial correlation is defined in general as r square y x1 dot x2 x3 up to xk. The correlation between y and x1 given the rest, or it may be correlation between y and x2 dot x1 x3 etc. up to xk. Okay, so what it is indicating? How a single explanatory variable is explaining the variation in yi given the rest of the explanatory variables, Any question regarding the definition of partial correlation? You are understanding? Are you understanding the difference between the simple correlation and the partial correlation?
Ma'am,
Yes.
so if we take the example of the demand function, so we could
Yes.
have a simple correlation between price and the income of the consumer. And in
Yeah.
case of partial correlation, we could have a correlation between price and income given the other explanatory variables.
No, it is not the price. Your y variable is demand.
Yeah,
Here,
sorry, my mistake, demand, yes.
demand and any one of the explanatory variables given the rest.
Yes.
Demand and price given the rest, or demand and income given the rest. This will be the thing.
ম্যাম
Yes.
ম্যাম তাহলে সিম্পল কোরিলেশনে বেসিক্যালি ওই ডিমান্ড আর প্রাইসটাই আমি জাস্ট কনসিডার করব, তো জাস্ট মানে এই দুটোই ভেরিয়েবলস এক্সিস্ট করে আর এক্স হচ্ছে এক্সপ্লেন্ড ভেরিয়েবল, তাই তো?
No, Rajdeep. If you have a bunch of explanatory variables, in case of simple correlation, you can calculate correlation between demand and price and everything, So there is no problem in calculation part. However, logically, In context of the regression analysis, generally we use the concept to measure the correlation among all explanatory variables to check whether there is multicollinearity or not. Okay.
আচ্ছা
If you consider the definition as I have written, R square YX, it is the relation between demand and price. Now you can consider the relation between demand, price, and income. Or you can consider the relation between demand, price, income, education. So it is possible to calculate these kind of simple correlation. However, there will be some context, there will be some logic to use the concept. These are all statistical definition. In context of the regression analysis, while we are using the statistical notions in our regression framework, there are some, ideas. We use these particular notion to calculate this particular notion to calculate that. So I am explaining that thing.
আচ্ছা তার মানে ম্যাম আমরা এই রিগ্রেশন অ্যানালিসিসে আমরা এই সিম্পল আর স্কোয়ারটাকে বার করব টু চেক ফর মাল্টিকোলিনিয়ারিটি।
মাল্টিকোলিনিয়ারিটি
আচ্ছা
মডেলে আমি বলে দেবো, সিম্পল মডেলে তো আমার অনেকগুলো এক্স নেই, তাই না?
হ্যাঁ হ্যাঁ
সিম্পল মডেলে আবার ব্যাপারটা হচ্ছে যে আমি লাস্টে বলে দেবো যে সিম্পল মডেলে সিম্পল আর স্কোয়ার, পার্শিয়াল আর স্কোয়ার, মাল্টিপল আর স্কোয়ার কোনো
হ্যাঁ একই কোনো ইয়ে নেই।
সেম।
হ্যাঁ
Okay. However, I am using capital R square in one place, then small r square I'll use in other place. So we need to understand what are the underlying things are there. In a simple model, the model is simple, and for that matter, we will be not able to distinguish between the simple, partial, and multiple. So far, I covered the simple and the partial, and I hope you are understanding. I have a single explanatory variable here. So if I calculate the simple correlation between y and x, that will be equivalent to calculating partial, because here I do not have a given set of variables. I have only one y and one x. Okay. So this is the idea. In case of simple correlation, the thing is different, Rajdeep. However, if we have a series of explanatory variables, logically, we use the concept of simple correlation to check whether there is correlation among the explanatory variables or not. Whereas, when we consider the partial correlation, we consider the explanatory capacity of a single explanatory variable in explaining the variation in y, given the rest. Okay, so how price of certain commodity explains the variation in demand given income of the consumer, taste and preference, geographical location, education, gender, etc. Okay, so this is the idea. Is it clear
হ্যাঁ
now?
হ্যাঁ বুঝতে পেরেছি, থ্যাংক ইউ ম্যাম।
Okay, next, this sentence is very, very important. The partial correlation is related to, this sentence. This is very, very important. This is related to each of the regression coefficients. Each of the regression coefficients. So let's explain this idea. Anyone wanted to tell me something?
আমি বলছিলাম যে ওই স্লাইডটাতে পার্শিয়াল কোরিলেশনের পাশে যেটা লিখেছিলেন কি ওয়াইআই না এক্সআই, ওটা বুঝতে পারিনি। হ্যাঁ, এইখানে হাউ এ সিঙ্গেল
The
এক্সপ্লেনেটরি
variation in yi, naturally, the variation in study variable or yi, given the rest of the variables. How a single explanatory variable is explaining the variation in yi, how it can be xi. We want to, cover, or we want to explain the variation in the study variable, isn't it?
হ্যাঁ 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 মানে
Okay.
একটা ভ্যারিয়েবলেরই তো ভেরিয়েশন নিচ্ছি।
I didn't get you.
মানে ম্যাম বলছিলাম যে ডিমান্ডেরই তো ভ্যারিয়েশনটা নিচ্ছি, মানে একটা ভ্যারিয়েবলেরই।
আরে একটা কথাটা বলো না, স্টাডি ভেরিয়েবল। একটা মিনস if I have a number of explanatory variables, it can be যে কোনো একটা. It's not that. I have to consider the dependent variable, the study variable, yi. I have to explain the variation of yi with the help of explanatory variables. TSS is equal to ESS plus RSS. So, TSS is the variation in yi. And with the help of different explanatory variables, we like to explain the variation in y, or the dependent variable. So how a single explanatory variable is explaining the variation in the dependent variable yi, given the rest of the explanatory variables. Better to write here, given the rest of the okay. Next, the line I underlined, the notion of partial correlation is related to each of the regression coefficients. So let me explain this sentence. So suppose my regression equation is given by okay, suppose this is my regression coefficient. Okay. Now what is beta 1 dy or del yi by del x1i given the rest of the explanatory variables? Beta 1 okay. Similarly, beta 2 is equal to del yi by del x2i given rest of the explanatory variables, and so on. It's not beta square. Okay, so this is the idea. Given rest of the explanatory variables, how the variation in yi will be explained by variation of a single explanatory variables. So if these are the concepts of the regression coefficients, beta 1, beta 2 to beta k, I hope you are understanding all of these regression coefficients are basically associated with the notion of partial correlation coefficient. Partial correlation is exactly doing this job. It is explaining the relation between yi and x1i given the rest, or yi and xki given the rest. Okay. So in this way, the notion of partial correlation in context of regression analysis is very, very important in the sense that these are actually related to the idea of regression coefficients. These are related to the definition of the regression coefficients. Okay? Are you understanding this line? This notion is related to each of the regression coefficients. Is it okay, or I need to explain it once again? Is it clear?
ম্যাম আরেকবার একটু বলবেন, মানে ওই বিটা মানে ডিওয়াইআই বাই ডিএক্স ওয়ান আই ওগুলো কি করে মানে রিগ্রেশন পার্শিয়াল কোরিলেশনের ইয়েটা হচ্ছে?
Okay, this is the basic regression. Okay, so we have, suppose x1i is price, x2i is price of substitutes, x3i is income, okay, x4i is education, x5i is gender, x6i is parental education, and so on. So things are going like this. Sorry, here I forgot to add the error term. Since I'm writing the regression model, I should add the random error component too. Okay, so this is the regression model having a number of explanatory variables. Then what is beta? Beta is change in y due to change in x1, isn't it?
Yes, ma'am.
What is the concept of beta? Beta, all betas are the gradients, nothing else. However, it's not so simple. It is not the relation between y and x simply. It is the relation between y and the particular x given the rest. That is, given the fact that price of the other commodities, income, test preference, geographical location, these things also explain demand. How much variation will be explained only by price of the commodity, or how much variation of demand will be explained only by education given price of the commodity, price of other commodities, income, etc. Or how much variation of income or what proportion of variation of income will be explained by gender or explained by, say, geographical location given the rest. The idea is like that. It is not simply, if it is a multiple regression model, if I have more than one explanatory variables, it is not simply dy dx. It is dy dx given other explanatory variables. Okay, so this is the idea. Are you getting it?
Yes, ma'am.
Yes.
So if this is the notion of regression coefficient, isn't it actually related to the notion of partial correlation? Partial correlation also measures this thing, correlation between y and x, given rest of the explanatory variables. Are you getting this point or still
Yes, ma'am.
problem?
Ma'am,
It is not r square y dot x1 sorry, yx1 dot x2 to xk is equal to beta 1. I'm not telling that. The notion of regression coefficient is related to the notion of partial correlation. The concept of regression coefficient is based on the notion of partial correlations. Is it now okay?
yes, ma'am.
Yes, ma'am.
Okay, so this is related to each of the regression coefficients. The notion of partial correlation is related to the idea of regression coefficients. Now again, in a simple model, when we have y is equal to alpha plus beta x plus u, this kind of concept, so it is the relation part. If you like to measure the partial correlation, what you can measure? You can measure the correlation between y and x only, because there is no given matter. So in case of a simple regression analysis, the simple r square will be exactly equal to that of partial r square. Okay. Finally, there is the notion of multiple correlation. Multiple correlation generally we define by capital R square, and it is y dot x1 x2 to xk. This will be xk. R square y dot x1, x2 to xk. That is, I have to consider all the explanatory variables we have in the regression model and their impact on y. So now I'm not considering one variable at a time given the rest. I'm not considering that. I'm considering these variables are there in my model. These variables are there in my model, you know. So how all of them together can explain the variation in yi. How all of them together can explain the variation in yi. If this is the concept, how all explanatory variables together can explain the variation in yi, we call it the multiple correlation, and we present it as r square y dot all the variables, all explanatory variables. Okay, given all explanatory variables, you know, how simultaneously all of them explain the variation in yi. So this is the idea. And in the last class, we found that if I consider all explanatory variables and we try to assess their capability at a time, we will consider ESS, explained sum of squares. Okay, so the notion of multiple R square, that is the explanatory capacity of all explanatory variables together given the explained variable yi, should be given by the notion ESS by TSS. So R square is ESS by TSS, explained sum of squares divided by TSS, or you can write this as or you can write this as same. Is it okay? Any question regarding the multiple correlations?
No.
Okay. And last,
ম্যাম
yes, yeah,
ম্যাম
yeah.
বলছি মাল্টিপল কোরিলেশন আর পার্শিয়াল কোরিলেশন কোথায় ডিফার করে এটা একবার বলবেন না?
In case of partial correlation, you are considering y and one of the explanatory variables. If you look at the definition, you know, here y and x1 you are considering given the rest. And here you are considering y only here, given all the variables. How all the variables together can explain yi. How? Okay.
Yes ma'am, yes ma'am.
In that case, y and one variable given the rest, and here y and all the variables. This is the difference. Any other question? And so if this is the definition of multiple R square, as I discussed in the last class, as we increase the number of explanatory variable in the model, the explanatory capacity of the model will increase, and that will in turn increase ESS, and so that ESS by TSS. So the R square definition indicates that larger the number of explanatory variables, better the measure of goodness of fit. If you consider so many explanatory variables, you know, in that case, you will be able to capture almost the entire variation in yi, and your goodness of fit, that will improve. This is the idea. Okay. Now here also you need to take a note in context of multiple correlation. You need to take a note. So R square is equal to ESS by TSS. This implies is it okay to all of you? This sentence is acceptable?
Yes, ma'am.
Yes, ma'am.
Question is, sorry, Linda. Okay, so this is the question. Should we go on increasing the number of explanatory variables then? If this is the idea, so continuously you need to collect the data on this variable, that variable, and should we go on increasing the number of explanatory variables then? Okay, answer is as we increase the number of explanatory variables, degrees of freedom number of observations less okay. So what I am telling that as we go on increasing the number of explanatory variables, I have some benefit because my ESS will increase and thereby ESS by TSS will increase, and that will improve my degrees of, that will increase my goodness of fit. However, it has a cost part too. It has a cost part too. As we increase the number of explanatory variables in our model, number of parameters we need to estimate, that is also increasing. For example, suppose my initial model is okay, then according to the suggestion, I am going to increase the number of explanatory variables. As I increase the number of explanatory variables from 2 to 3, the number of parameters I need to estimate, that is also increasing from 3 to 4. Initially beta naught, beta 1, beta 2, and now it is beta naught, beta 1, beta 2, beta 3. So as we increase the number of explanatory variables in our model, that brings an additional regression coefficient, which indicates we have to estimate one or other parameters in the model, So as we go on increasing the number of explanatory variable, on one hand, it is true that ESS is increasing as ESS by TSS is increasing. However, it is reducing the reliability of the model because the degrees of freedom which we measure by n minus k, that is falling. So there is a cost part too. There is a cost part too. Please add, hence, we need to have a trade-off. We need to have a trade-off between, we need to have a trade-off between the improvement in ESS and reduction in DF, reduction in degrees of freedom. Please add R square, capital R square, as a measure of goodness of fit captures the benefit part. However, it fails to capture the loss of degrees of freedom, fails to capture the loss of degrees of freedom. In this context, we consider the notion of adjusted multiple R square, defined as R bar square. R bar square is equal to ESS by degrees of freedom divided by TSS by degrees of freedom. Has PT sir started his practical sessions?
Yes, ma'am, he took a class this Monday.
Has he started the regression model? Has he started regression model? Regression?
হ্যাঁ ম্যাম একটুখানি স্টার্ট করিয়েছিল ট্রেন্ড লাইনের আগে অবধি।
Have you seen the regression output?
মানে ওই ডেটা অ্যানালিসিস দিয়ে করেছিলাম, ওখানে অ্যানোভা থাকে আর থাকে রিগ্রেশন, সেরকম কিছু একটা করেছিলাম। হ্যাঁ
কিছু একটা বললে তো হবে না, you
এখন
need to check all these things. What are the outputs you are getting? You know, you got all this. If you run a regression equation in Excel, actually you got 3 tables, you know. So in the
ম্যাম আমরা এখনো করিনি ওটা।
সেটাই জিজ্ঞেস করছি, তোমরা
হ্যাঁ
করে?
আমরা এখনো করি, আমরা মানে স্যার শুরু করবে কাছে, এখনো করিনি আমরা।
Okay, fine. So whenever you will get the regression output using some software, you will get R square, capital R square value is given, also R bar square value is given. Because R square as a measure of goodness of fit fails to capture the fact that as you increase the number of explanatory variable in the model, degrees of freedom is falling. Therefore, we need to introduce an advanced notion to measure the goodness of fit, and that advanced notion is the notion of adjusted multiple R square, which we define by R bar square. That R bar square is ESS by degrees of freedom divided by TSS by degrees of freedom. Okay, so in each of the case we will divide the elements by their respective degrees of freedom. Okay, so when I'll introduce the k variable model, I'll again repeat all these things, how we are defining R bar square, etc. However, to begin with, you need to keep in your mind, in a simple framework, we can present everything very simply, because you know, R square, R bar square, multiple R square, simple R square, partial R square, everything is fine, and that we do not need basically R bar square, because here there is no scope of increasing the number of explanatory variables. Here I am considering a simple model, considering a single explanatory variables only. So my model is this one. So I have a single explanatory variable, and as long as it is a simple model, I do not have the scope that I'll go on increasing, improve ESS, and that in turn will reduce the degrees of freedom. So these ideas are not coming here. However, we have to keep all these things in our mind, that these things are there. So in a regression model, it is not that when you are estimating a demand equation, you will collect data on, you know, say 100 or 200 explanatory variables, because that will improve the explanatory capacity of your model. So idea is not like that. You have to consider, you need to optimize, you know, you need to make a trade-off between the degrees of freedom and the number of explanatory variables that should be incorporated in the model. So this is all about the different notions of R square. Okay. In different contexts, we will bring everything. Just take a note, in case of a single model, a simple model, in case of a simple regression model, simple R square, simple R square is equivalent to partial R square. Both the R square is small in case of partial and simple. Simple R square is equivalent to partial R square is equivalent to multiple R square. Simple R square is equivalent to partial R square is equivalent to multiple R square. Any questions so far? Anyone, any question?
Ma'am,
Yes.
ma'am, so the adjusted multiple R square, it is only required in a model with more than one explanatory variable, right?
Yeah, when you will get the Excel output, you will get, both capital R square and R bar square, because in case of software, we write a single program. We do not write a program for one explanatory variable, 2, 5, 10, 100. Since there will be a single program, inbuilt program, when you are running the regression model, you will find the report of capital R bar square too. Okay. So in case of a simple model, you will get the report, when you will get the information, you will get R bar square there. However, in case of a simple regression model, none of the things, will differ from each other, because you have a single explanatory variable only. You have a single explanatory variable only. Okay.
Yes, ma'am.
Okay, so with this, now I'll go for a numerical exercise. Okay, so we discussed about different properties of beta hat, etc. We have discussed about how to estimate the parameters of the model, etc. Though today I'll not discuss about estimation as such, because once we complete the hypothesis testing, we will be able to cover the parts of our analysis. However, today I'll discuss a single numerical exercise, which is based on the idea of we can have a series of unbiased estimators of the regression coefficients. However, among them, the OLS estimate gives us the minimum one. So that kind of numerical exercise I'll discuss. And I'm giving you a homework. Please derive the covariance between alpha hat and beta hat. Covariance between alpha hat and beta hat. This one, covariance alpha hat and beta hat. So please calculate this on your own. So homework is derive covariance between alpha hat and beta hat. Okay, and I'll discuss one numerical exercise for you.
ম্যাম,
Yes.
আমি বলছিলাম যে এই একটা এক্সপ্লেনেটরি ভ্যারিয়েবল আর মাল্টিপল এক্সপ্লেনেটরি ভ্যারিয়েবল কি একসাথে আছে, মানে একসাথে কি থাকবে, মানে নাকি পরে আবার আমরা করব?
পরে মাল্টিপল এক্সপ্লানেটরি ভেরিয়েবলস এর কেসেস গুলো ডিসকাস করা হবে। Now we are talking about the simple regression model only. However, we are keeping some notes in some context, because after completing all these things, we need to understand several points related to the multiple regression model. Okay. Because optional paper, when we will go for the next semester, and econometrics advanced paper or the optional paper is there, everything, those who will take that optional, they will learn everything in details. However, many students may not take that paper. Therefore, in the general paper, I'll give some idea about the multiple correlation too. Okay, rest of the things will be discussed in the optional paper. However, since that is the optional paper, so I'll raise several issues related to the multiple regression analysis. Okay, Because you will find that in general, those who will go for admission of different institutions, you will find that the questions are mainly based on qualitative variables. Questions are mainly based on different issues related to the multiple regression analysis. So all these things happen because all the tests are for elimination, so these things happen. So those who will not take the optional paper, or will go for different options, they also need to know at least some points, so that if requires, they can address this kind of questions at least to some extent. Okay, so this is the thing. Darpok, I think you got
হ্যাঁ হ্যাঁ,
answer.
yes, ma'am.
So I hope everybody wrote what is the homework. You need to find out covariance between alpha hat and beta hat. Now, the question I am giving, or the exercise I am discussing, that is from Johnston and Donato. Johnston and Donato. It is 1.10, exercise number 1.10. However, please write down the point, write down the problem, and then we will solve it. The fixed values of x, capital X, the fixed values of capital X in a problem are as follows. The fixed values of capital X are as follows. We have 6 values, x1, and the values are 1, 2, 3, 4, 5, 6. These are the values. Okay. Next, an econometrician with no calculator assumes that, or proposes, with no calculator, proposes to estimate the slope of the linear relation between y and x, proposes to estimate the slope of the linear relation between y and x by 1/8 y6 plus y5 minus y2 minus y1. Okay, so actually this is beta to by his or her proposition. So the researcher is proposing, the linear relationship between y and x, or the slope of the estimate of the slope of the linear relationship between y and x is given by these 1/8 y6 plus y5 minus y2 minus y1. Next, show that this estimator is unbiased. Show that this estimator is unbiased. Deduce its sampling variance deduce its sampling variance and compare the sampling variation of the least square
ম্যাম দিস এস্টিমেটেড ইজ আনবায়াসড এর পর কি বললেন?
that is first part. Next, derive its sampling variance and compare this with the sampling variance of the least square estimator of the slope. And compare this with the sampling variance of the least square estimator of the slope. Okay, so one researcher is proposing this will be the estimator. So first we have to check whether this estimator, the alternative estimator for measuring the slope of a regression model, is unbiased or not. Because unbiasedness is not a unique property. We can have a number of unbiased estimators, you know. And then we have to calculate the variance for this proposed estimator. And we need to calculate the variance of the least square estimator. And we have to compare. If we find that the variance of the least square estimator is smaller than that of this proposed estimator, then the MVUE property is retained with the OLS estimator will be once again proved. So numerically, we are trying to check whether the OLS estimator provides the minimum variance or not. To check this, we are proposing an alternative estimator. We will calculate expectation of this. If it is an unbiased estimator, in the next step, I'll calculate the variance of this alternative estimator. Then I have to calculate the variance of the least square estimator. And we have to compare the two. So are you understanding what are the steps you need to do? Are you understanding?
Yes, ma'am.
Rest of the students? Shobnil, are you understanding?
Ma'am, I understood the concept, but not sure like how to do the sum.
Yeah, that you are not understanding. However, whether tell me you are understanding what are the things you need to do.
Yes, ma'am. Yes, ma'am.
Okay. So let's start. So let's consider this alternative estimator is beta tilde. This is the alternative estimator, beta tilde. Okay. So we need to check whether if expectation of beta tilde is equal to beta, in that case, you know, beta tilde is an unbiased estimator. Okay. And for this entire problem, we will consider the linear relationship between y and x as yi. So we are understanding we need to calculate expectation of beta tilde. As I mentioned, we have properties based on ui, the random error term. So always if there is y, we have to convert the things in such a way so that we get the u in our structure. Because expectation of ui is equal to 0, we know. The variance of ui is a constant, we know. Covariance of ui uj, that is equal to 0, we know. So given this value of beta tilde, would anyone tell me how I'll proceed before calculating expectation of beta tilde?
Ma'am, we need to compute all the y's in the estimator. So y6, y5, y2, and y1.
Y6, how I'll present?
Ma'am, it'll be alpha plus beta x6 plus the random error u6.
Yeah. So everybody should move like that. Y6 should be replaced by alpha plus beta x6 plus u6. Y5 will be written as alpha plus beta x5 plus u5 and so on. Please do that. And then you take beta common, you will find that alpha alpha are cancelling. Take beta common for x6 plus x5 minus x2 minus x1. Then plus, together you keep the u values. So please check whether you are ultimately getting these things or not. So please check whether you are getting this or not.
Yes, ma'am.
So you are getting this. In the next step, you have to consider expectation of beta tilde. You know the values of x6, x5, x2, x1. So before doing that, before taking expectation, you can put the values too. What is the value of x6? 6. So what is the value? 6 plus 5 minus 2 minus 1?
8.
8. So there will be a cancellation. So what is the first term?
Beta.
First term then? What is the first term?
Beta.
And you have the next step, take expectation of beta tilde and tell me what you are getting.
I'm 0. I mean beta, sorry.
Beta. Rest of the students, what you are getting?
Beta.
Ma'am,
Beta. Why you are getting beta?
because expectation of the error term is 0.
Yeah. So expectation of beta tilde is equal to beta as so beta tilde, that is this alternative estimator is, an unbiased estimator of beta. So the researcher proposed really an unbiased estimator of beta. Okay, so please add, hence beta tilde is an unbiased estimator of beta. Beta tilde, that is a proposed alternative estimator of the regression coefficient, is an unbiased estimator of beta. Everybody could complete up to this? So next, what you need to find out? Look at the question. What you need to find out?
Variance of beta tilde.
Variance of beta tilde, yes. So try to derive variance of beta tilde. We have to calculate variance of beta tilde, which is variance of this one. So variance of y is equivalent to variance of u. Variance of y, because other thing is the intercept of the model, xi is non-stochastic. So variance of yi is equivalent to variance of ui. Okay, so keeping this point in your mind, can you tell me what will be the possible value of the variance or how I'll proceed?
Ma'am,
Yes.
couldn't we do it in the expectation form?
No, that is not needed at all.
Ma'am, but we have a relationship between beta tilde and beta and that error term, so we can use that, I think.
Okay, Aratrik has placed his idea. Anyone else?
Number beta is constant, right?
Beta is a constant, We have to calculate variance of beta tilde, not beta. Variance of the estimator. I'm giving you a hint. Variance of yi is equivalent to variance of ui. What is variance of u6?
Sigma u6 squared.
Sigma u6 square.
Sigma u squared, sorry, homoscedasticity, so sigma u squared.
So simply sigma square. What is variance of u5?
Also sigma squared.
And if the variance of y is equivalent to variance of u, so how I'll proceed?
मैम आंसर की जीरो হবে मैम आंसर की जीरो হবে
কি করে অভিষেক জিরো পেলে বলো
ম্যাম বিকজ variance of y6 plus variance of y5 এটা হলো 2 sigma squared আর ওদিকে -2 সিগমা স্কয়ার, তো 0 হয়ে গেল।
ভেরিয়েন্স কি নেগেটিভ হয়?
না মানে না মাইনাস, না 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 সরি সরি।
Ma'am,
তাহলে
variance of
বলো,
beta tilde equals to variance of beta আসছে?
variance of beta tilde is equal to variance of beta. Everything will be presented in terms of sigma square.
Yes, ma'am.
Ma'am, 1/16 sigma square. Answer.
1/16 sigma square. Right answer.
Okay.
1/16 sigma square is the right answer. So it is, basically 1/64 into 4 sigma square. Isn't it?
Yes, ma'am.
It is 1/64 into 4 sigma square.
Yeah.
Is it understandable? Any question? Is it okay to everyone? Are you understanding the matter or not understanding? Should I need to explain anything? Abhishek, now you are getting the definition or value?
Yes ma'am.
Olipriya, getting the value?
Yes, ma'am.
ম্যাম বলছিলাম যে এই ভ্যারিয়েন্স অফ ওয়াই আর ভ্যারিয়েন্স অফ ইউআই টা কেন সেম হবে আরেকবার বলুন।
Look at the regression equation. I hope you will understand. Variability of y is depending on variability of u, dispersion of y. U is the only random variable here. Y is also random. Y is random because of randomness in u. So variance of yi will be equivalent to that of variance of ui.
ওকে।
Okay, so we got the variance of the alternative estimator sigma square 16. So up to this we could complete. If anyone have any question, please ask me. Otherwise, we have to go for the second part, the other part. We need to calculate variance of beta hat OLS, and we need to compare variance of beta hat OLS with variance of beta tilde. So is this part all right to everyone? In that case,
Yes, ma'am.
you have to go for the other part. Now, given the information, how we will calculate variance of beta hat OLS? First, tell me what is the formula for the variance of beta hat OLS?
Expectation of beta hat minus beta whole square.
What is the final formula?
মানে একদম এন্ডে
Variance.
সিগমা স্কয়ার ইউ বাই ভেরিয়েন্স এক্স
Sigma u square, sigma
বাই
by
ভেরিয়েন্স অফ এক্স, মানে সামেশন এক্স আই মাইনাস এক্স বার হোল স্কয়ার।
Okay, this is a numerical exercise, isn't it? Okay, so you need to calculate this summation xi minus x bar whole square given the observation on xi is.
Yes ma'am.
Okay, so you construct a table like this. And find out the values. What is x bar? First tell me that. you have values, 1, 2, 3, 4, 5, 6.
Ma'am, 4.2.
4.2. 3.5.
3.5. 3.5.
Okay, I made a mistake. Ma'am.
I am getting this to be 3.5. Please check.
Yes, ma'am, 3.5.
So find out xi minus x bar, 6 values. What are the values? Oishwarya, did you calculate these values?
Ma'am,
ম্যাম
17.
6.25 ম্যাম ভ্যালুস গুলো হচ্ছে 6.25 মানে মানে আচ্ছা ওগুলো হচ্ছে -2.5 -1.5 -0.5 0.5 1.5 2.5 আর ওইদিকে
নেক্সট
আসবে
কলামটা ক্যালকুলেট করে ফেলো।
17.5.
17.5 will be the total. First tell me the values of xi minus x bar whole square.
6.25
হ্যাঁ
2.25 2.5
2.5.
sorry 0.25 sorry 0.25
After
টোটালটা 17.5 আসছে।
totalটা 17.5 আসছে। So if total is 17.5, then tell me what will be the variance of beta hat?
Sigma squared by 17.5.
Sigma squared by
17.5
what was the earlier value?
Sigma square by 16.
sigma square by
Sigma
16
squared by 16. Which one is lesser?
First one.
second one beta was less
So though both the estimators are unbiased, OLS estimator is unbiased, we know, and the alternative estimator is unbiased, the variance is minimum for the, or variance is lesser for the, which estimator?
Beta hat
OLS
OLS.
beta hat OLS
Yeah. So hence okay, so the construct we are doing theoretically, the question may come numerically too. Okay, so the idea may be theoretical idea, so in different ways the question may come. The same thing we are doing here numerically, proposing alternative estimator, checking its unbiasedness, and then calculating the variance of the OLS estimator, comparing the two and coming to the final conclusion variance of beta hat OLS is the minimum variance unbiased estimator. Anyone, any question? And I told you to derive covariance alpha hat, beta hat. This you need to find out. Not for these numerical exercises. In general, this is the homework. Find out covariance between alpha hat and beta hat. Okay. Roll number 1, Ritam.
Present, ma'am.
So now you got time to come back.
না না ম্যাম এরকম না পরীক্ষা
বুঝলাম। প্রত্যুষ?
Yes, ma'am.
Shoham is absent today.
Present, ma'am.
Okay, next. Shreya Shaha. Shreya. Rajdeep.
Present, ma'am. Present.
Shreya is
Ma'am, present. Ma'am, present.
Sushama.
Yes, ma'am.
Goshia. Shreyoshi.
Present, ma'am.
Shreya.
Excuse me, ma'am.
Present, ma'am.
ঐশী বলছে একটু ঢুকতে দিতে হবে।
Huh?
ম্যাম ঐশী বেরিয়ে গেছে, ও ঢুকতে একটু মানে অ্যালাউ করতে বলছে ক্লাসে।
Oh. Where is she? I'm not getting. Okay, at this moment she is not here. If you know, again you find this thing, please let me know.
Okay.
Ghoshia is absent today. Okay, now I think she's there. Acha. Abhishek.
Present, ma'am.
Adesha.
Present, ma'am.
Boshya.
Present, ma'am.
Mohini. Shivani.
Present, miss. Ma'am. Ma'am. Ma'am, I'm Borsha. I'm present.
Acha. Okay, Ritano present, তাই তো?
Yes, ma'am. ও লিখেছে চাটে।
Mehuli. Shivani. Shivani বলেছে।
Present, miss.
Yeah. Shukanna.
Ma'am, present.
Shreyoshi. Shreyoshi Das. Srijita.
Present, ma'am.
Shinjini. Priyanka. ঐশ্বর্য। Shagnik. Aratrik.
Yes, ma'am.
Ma'am, ma'am, Aishwarya present আছে লিখেছে।
Dhruv is
Ma'am.
present.
Yes, ma'am. Present, ma'am.
Lakshadweep.
Present, ma'am.
Srijani.
Present, ma'am.
ঐশী। ঐশী তো ঢুকলো। রাতুল।
Present, ma'am.
Ratul, this time you are understanding the matter?
Yes, ma'am. Okay, ma'am.
I didn't get any question কোনো সারা শব্দও পাই না। What you are doing in the class, I don't know.